Example number 10. The pH of a 0.24 molarity chlorous acid solution is 1.335. What is the value of Ka of chlorous acid? The temperature is 25.0 degrees Celsius. This is the summary of this problem. The first step to use the flowchart is to figure out how many solutes in the solution. Chlorous acid is the only solute in the solution. The next question we have to answer is chlorous acid an acid, a base, or a salt? From the name, chlorous acid must be an acid. We can also tell chlorous acid is an acid from this symbol, Ka. Ka represents the equilibrium constant of an acid, which we call acid dissociation constant. Then, what we need to do next is we need to calculate the ratio between Ka and the initial concentration of the chlorous acid. But unfortunately, Ka of chlorous acid is what we are looking for. Therefore, we cannot calculate the ratio between Ka and the initial concentration of chlorous acid. But the good thing is we only have 3 choices. Even for the worst scenario, we can try them out one by one. Let's do it now. We can calculate the equilibrium concentration of the hydronium ion from the pH. After our calculation, the equilibrium concentration of the hydronium ion is 0.0462 molarity. Let's look at the flowchart again. If it is the first case, the equilibrium concentration of the hydronium ion should be equal to the initial concentration of the acid. This is the concentration of the hydronium ion. This is the initial concentration of the chlorous acid. We know that they are different, so the first scenario does not apply. Then let's try the third scenario. The reason we want to try the third scenario before we try the second scenario, because generally the third scenario requires less work to calculate Ka. Then the second scenario. Let's do it now. This is the math of the calculations. If you have difficulty to understand the math, you can slow down the video. After our calculation of Ka, we need to check our assumptions because we can only use this equation to calculate the equilibrium concentration of the hydronium ion if the ratio between Ka and the initial concentration of the acid is less than 10 to the negative 3. Let's check that now. As we can see here, the ratio between Ka and the initial concentration of the acid is 3.7 times 10 to the negative 2. This number is not smaller than 10 to the negative 3. So the result from our calculation is not consistent with the assumption. Unfortunately, we have to use the ice table to calculate Ka. Let's set up the ice table. If you have a problem to set up the ice table correctly, please watch my previous videos. We know that X represents the equilibrium concentration of the hydronium ion, which we already know the value, 0.0462 molarity. If we know the value of X, we can plug it into this equation to calculate the value of Ka. If you plug the numbers into a calculator, you get Ka equal to 0.011. Can you follow my example to work out this problem by yourself?